So yesterday I was showing you how to convert these rates from different time period defined in a different compounded period defined in different year, the time period t, to whatever your desirable factors are, right? And one of the question which Parikshit later asked me, it was a good question which I think got diluted while I was making jokes about Tesla. So he says that where in my real life I will use this? I'm like, okay, yeah, that's a good question. Why would you even use this kind of a conversion in real world? But see, in this case, uh, Tesla is a little bit more respected company, so they can command power and they can perhaps mention that I want quotation in only this format, right? They can give their contractor that kind of an information that I want you to report numbers in semi-annual or annual. I don't want to do the calculation. You give me the number, right? Tesla can do that. But you as a consumer, if you are trying to find loans from different banks for buying a car, you can't bend the reporting rules of the banks, right? Bank will say, we are giving you this rate, these are our terms and condition. You decide, you read the terms and condition and you find out which is going to be the best for you, right? So precisely, different people, different banks, different lending companies have different objectives and they maintain different level of transparency with their customers, and they might represent all this information in a not a standard manner, because there is no guideline that you need to only report numbers in this. It's all a marketing play, right? So therefore it has a practical value. It's not a hypothetical situation that I have created only to make your life difficult. It is a practical value significance, right? Yeah, not an example in a government client or such kind of like high contract bids where the government can negotiate the terms of reporting, okay, how your bid should look like, this should be reported and all. That is a different matter. But still, you can use this kind of concept and you will face this concept in the real world as well. Okay. Any questions again in this formula that we tried yesterday? Is this clear? Can we move on? Or any doubt? All right. So, let's move to more complicated stuff. In the same. So far I have just shown you how to adjust the interest rate according to whatever the compounding period has been given to you, right? But we have also derived all these factors of standard calculations, A by P, P by A, F by P, whatever we have been deriving so far. How do you adjust those factors matching the condition of the interest rate that has been satisfied, right? First of all, do you need to modify the factors? For example, a typical formula, whatever, let's say A by P, has two variables, right? Do you need to even change the formula a little bit in order to accommodate the rate, is my question. Why not? You can just change I to match what? Formula setting. What is formula setting? What are we actually, what is the other variable that compatibility has to be assured? Yeah, but I always made you pay attention to the some of the things. For example, the time gap between the first payment of G series versus the first payment of A series, and correspondingly P series and all, right? P by G formula. So the time period is the main. If your cash flow shifts a period here and there, the same formula does not hold true, right? So depending upon your compounding period unit, you need to adjust your N value. Some sort of an adjustment is required to represent that compounding period is equivalent to your units of N, right? That's the idea. But what I'm saying, again, I will reiterate, what the correct approach is, you are right, you need to redefine the I percentage rate such that it matches the formula. You do not need to change the N, but the idea is the formula can differ, because if you do a different transformation, the cash flow occurrence will change. And then accordingly, how many times compounding has to occur, that will differ. So it will become more clearer to you, but that's the whole idea. Why do we even need it? And I'll introduce another term called payment period, capital PP. You can kill me that why sir is introducing a lot of new terms every time. Essentially, it's an equivalent of the term T that we saw yesterday. But in this case, it makes more sense and I'll explain you a little bit more. So payment period is defined as capital PP. This is the length of time between the cash flows. So if your cash flow series is occurring every month, then your payment period becomes 1 month. If you are dealing with daily cash flows, your payment period becomes daily. So payment period is governed by your business needs or the kind of transactions you are handling. If you are in a banking industry, daily. If you are in a stock market industry, even hourly, even second basis payment period becomes important. But second basis, the rate does not get compounded. And again, the error can accumulate. So depending upon what is the need, compounding period is market driven. It is somebody giving you the external rate. Payment period is your business driven needs or your own personal needs or whatever the situation you have been given in a particular question. Therefore, there has to be a match between them, and that's what we are trying to do in how to reflect the formulas according to them, right? So payment period is the length of time between cash flows. Compounding period is the shortest unit of time over which the interest is charged or earned. So this remains the same what we saw yesterday. So for example, the 8% per year compounded monthly, the CP here is essentially a month, right? So it is common that in real world PP and CP are not coinciding, and that's where all the factors that we have calculated needs to be adjusted. Why? Remember this, everything that we have calculated so far, all the formulas of these factors that we have calculated so far are based on this assumption that you are defining the rate in per payment period. N is defined as number of payment periods such that your compounding period is equal to payment period. All the formulas that you have derived so far are under this assumption, right? Your payment period becomes, if you are talking about future value, the N is the number of years, for example. In that case, I am also giving an annual rate. So you can directly use the formula, right? Whatever A by P ratios you are calculating, so far the rate has been consistent with the number of period or the unit of period and the assumption has been that compounding is also matching exactly with the payment period. But this is not the case in the real world, and you can have 3 types of cases to deal with. So on the left hand side here, your payment period, which is the time difference between the cash flows. Of course, you could argue that, sir, not every cash flow is occurring on the same, but on an average, you'll be able to get an idea whether you want to adopt a monthly cash flow, an yearly cash flow, and things like that. So this is your payment period in this example, which is equal to 1 month. But I am defining that compounding period is given to you as quarterly basis, right? So in this case is where CP is less than PP. Making sense? In the middle part of this series, the payment period is 1 month. The compounding period is also 1 month. So CP is equals to PP. So in this part, all your formulas can be directly used because this condition holds true. In the right hand side of this curve, your payment period is 3 months, but your compounding is happening on a monthly basis. So your cash flows are bit sparse, but your rates are getting charged much more frequently. Your interest is getting accumulated much more frequently. So you need to take care of those kind of situations. Okay. So this is when CP is, no, sorry, I made a mistake. So this is the case of CP greater than PP. This is the case of CP greater than, less than PP. Okay. So far fine, able to follow the logic. Now, remember these golden words, always and always change the effective rate. All you need to do is, depending upon the compounding information, you need to identify the effective rate per payment period. That is what you have to do. Then your N does not need to change because N is already number of payment periods you are dealing with. So N does not have to modify. All you have to do is bring your interest rate, calculate the effective interest rate per payment period. Making sense? Payment period we have already dealt with. It is equivalent to the T kind of transformation, that T required kind of transformation that we yesterday dealt with a lot of questions also, right? All right. So case 1, when your payment period is actually greater than equal to CP. So which case? basically on this side of the cash flow series, right? So in this case, this is pretty simple. It will typically be given nominal interest rate, which is, let's say in this case 15% per year, and I am saying that compounding is happening on a monthly basis. So in this case, your CP is a month. This particular T is a year. Find P or F for a 2-year span. So what is my payment period? Year or 2-year or what? Can be anything, but essentially year is the unit that I am looking at. 2 is not relevant right now, you can adjust it, but 2-year is something that is, because once you know the annual, the 2 or 1 year does not make sense as long as that you are considering it an annual basis, right? So we are dealing with payment period also in a yearly basis, okay, in this particular question. So how do you do the transformation? 15% per year compounded monthly. So your effective interest rate per month is 15 by 12, which is 1.25% per month compounded monthly. Now you want to calculate on a yearly transaction. So you can convert this rate to an effective annual rate using the formula, which comes out to be 16.076% compounded annually. Now, since you want to use P by F formula, this rate you have used and the number of periods you have defined as 2, which is the number of years. So what I have done is, I have converted the rate, whatever the rate was expressed, I have converted that rate into per PP, which is the payment period unit, and then number of PPs I am not changing. I am not worried about that. Why? It will become clear. Give me some time towards the end of the course, not the course, lecture today. You will get more clarity of why this works and why it doesn't work, kind of a idea. Alright, some examples. So let's say you have a cash flow series, $500 semi-annually for 5 years. What is PP here? Year or semi-annual? How many for semi-annual? Your period is semi-annual because you are actually paying every 6 months $500. So the time difference between two cash flows is what you are interested in. That is semi-annual in this particular case, right? So N, the 5 years, for 5 years is the total duration. So that will help you determine the number of semi-annual periods. But the payment period in this case is 6 months. Okay. So let's say if I am giving you 16% per year, compounded semi-annually. Your problem is to find P given A. So what I have done is, since this is, I am worried about semi-annual, I will convert this nominal rate 16% per year compounded semi-annually to a semi-annual effective rate. What will be that? 8%. The number of semi-annual periods would be, because you are dealing with total 5 years of cash flows, so that becomes 10. And your formula becomes this. This is the P by A formula. Making sense? This is clear? Okay. Let's go to the next example. This is $75 monthly for 3 years. What is payment period? Month. Your rate is 25% per year, compounded monthly. So what is effective rate per month? 2%. You have been given, you have to find F, you have been given A. So what the formula? A by F formula? No, F by A formula, 2% and total 36 months in 3 years, you can use this. Making sense? What you have done, this formula is effectively doing what? For each of the month, for 36 months, you will have equal payments. And ideally, to use this formula, you need one interest rate that is commonly used. That is, you have already found effective rate per compounding per monthly in this case. Making sense? Okay. Let me give you another example. $180 quarterly for 15 years. What is your payment period? And your rate is given 5% per quarter. Do you need to change? Good. Find F given A. Formula is pretty clear. How many quarters in 15 years? 60 years. Your formula becomes this. Okay. $25 per month increase for 4 years. What is the payment period? Year, month. Rate is already given as 1% per month. So you don't need to change. You have to find P. You have been given a value of G, which is the gradient in this case. This is a gradient series. You have to do the formula of P by G, 1% for 4 years. How many months? 48 months. Okay. Finally, $5,000 per quarter for 6 years. What is your payment period? Quarter. Your rate has been given to be 1% per month. What is the quarterly rate? 1/3. How many months in a quarter? So the rate should be 1/3 or at least greater than 3 times the multiple. Do the calculation. 1% per month, convert it to a quarterly rate. Give me an answer. What is the formula? 1 plus to the power. Okay. So this will come out to be 3.03%. You are doing with 6 years. How many quarters in 6 years? 24. You adjust the formula to get the answer. In every question, we are converting the rate, making it equivalent rate for per payment period, which is derived by your needs of the question, and then you are using the formula if you want to use the formula. Making sense? Okay. Let's make it complicated. So this is a totally, I don't find any physical significance of this question in the real world, but let's do this. Okay. So what does the question say? You have this annual series which is given to you, which is on the series on the bottom side. This is given to you. Okay. You as an investor are interested in finding, instead of this series, what would have been an equal payment for per 6 months. I can give you a slightly modified version of this question of where it would be a useful concept. Instead of, let's say, 1 year, so the bottom time unit is on the years, the top time unit is on the 6 months. Just multiply it by twice. Let's say your cash flows are happening every 2 years. But every 2-year concept is not easy to understand for people, because it's very easy. Okay, in a yearly basis, what is my cost? Like annual cost, you are always interested because your financial cycle typically runs in an annual manner. So if you do that, this question makes sense. Specifically this question, to me, real life not making sense, but of course investing cycles are also lesser than 1 year as well. So you could be interested, okay, every 6 months, how much is the amount that I'm getting out of this investment? That could be a equivalent of this question, right? So essentially what I have given you is, this bottom series is given. I have to find how much would be the equivalent A value per 6 months, which is denoted by these series over here. If the rates are of these two types, first is the 8% compounded semi-annually, second is the 8% compounded monthly. Okay, all tricky that we have learned so far is in this question. You understand the problem statement? The bottom cash flow series, you have to convert to an equivalent cash flow series given at the top, which A value you have to determine, because it is having, every 1 year it is having 2 A payments. That's the question, right? And the first rate that has been given to you is 8% per year compounded semi-annually. Second rate that has been given to you is 8% per year compounded monthly. What is the basic concept? How do we deal with these questions when you have to find an equivalent? No, basic concept, forget about the compounding period and all. Idea is you bring the cash flow to one point, you distribute that 1 point cash flow again to the desired series that you want, right? So what I'm going to do is, I'm going to bring all these cash flows into one single point, and then I'm using this value, I'm going to redistribute in the another equivalent series that I want to estimate, right? You could have done it with any other point of time in this question. You could have converted to a final value. Also, principle remains the same, right? Now let's say how to deal the question. So the first part, 8% per year, compounded semi-annually. What is your payment period in first part? See, there are two transactions happening. First step is converting this to a present worth and then converting it to, right? This is clear? For step 1, what is the payment period? Annual basis, right? It's an year. So, and the current rate has been given to me is compounded semi-annually. So, I need to convert that rate to what? Annual basis. What is that rate to on an annual basis? Formula is 1 plus number. What's the answer? 8.16%. So using this, step 1 is taken care of, right? Now you can use, this is a normal p value, this is a series, you can backtrack the formula for how many periods? 10 years, right? So P first payment does not change. This $200,000 equivalent converted to a present worth using P by A formula. Rate is 8.16% on an annual basis that you've calculated for 10 years. This amount comes out to be some 4.32 millions. Okay. Now that question, the second part of the question is, you need to find an equivalent A per 6 months. Right? What is the payment period now? For step 2, what is the payment period? 6 months. What is your compounding rate? Compounding period, what is? So what will be your rate? 4% or higher or lower? 4%. So you use this method to redistribute the cash flows. How many periods total now? How many semi-annual periods in 10 years? 20. So you use this formula, the P value that you calculated in this part, you redistribute that using the A by P formula, 4% rate for 20 periods. This is the value of A. Clear with me how the transformation is happening? There are 2 steps. Each step will have their own payment period. Each step will have their own compounding period effect. The rate would change. There is no one uniform rate that you are using in this whole question. Right? Second part. Step 1. What is the payment period? Is a year. Your rate has been given to you on what's the formula? Power? Sure? What is the rate? Option 1 is 8.3%. What about others? 8.29. Okay. What else? What's the answer? 8.3? Everyone getting the same? Right. So it's 8.29%. 10 periods, it becomes, the value comes out to be 4,32,000, again 4.32 million, slightly different than the previous one. I think 1 0 is extra here, we'll have to see. If you notice this error, let me know, I'll correct my slides. I think 10 could be extra there. Right? Slightly different answer because the rate is also different. Now, second part, the step 2. What is your payment period now? 6 months. What is your CP? What will be the rate? What will be the rate? 4.77. 4.07%. Everyone getting the same answer? Sure? How many periods now? Okay? Everyone on the same page? How the transformation happens? Always break the bigger problem into smaller steps. You will not be confused. What happens is when you get comfortable with this kind of a transformation, you try to combine multiple calculation in a single step, and that's where the errors happen, right? So you need to be careful, and again I'm emphasizing a lot, once you have drawn the cash flow correct, your problem is half solved. Everything is governed by the cash flow. So please make special attention to, when you are doing every question, try to make a cash flow. If your cash flow is wrong and you're getting correct answer, it's just by coincidence. Cash flow has to be correct in order for you to get an answer which is correct. Okay? Always, whenever you are trying to practice, make it a habit that you are drawing cash flow. Even if it is not asked in the question, it helps you clarify your thought. It helps you clearly indicate what are all the transformations you need to do. Okay? Alright. Okay. Let's look at another case. So the first cases that we covered, it basically all the time where CP was greater than equal to PP. No, less than equal to PP. That cases we have already covered. Now comes the complication of when payment period is less than the compounding period, right? So what is happening is your payments are more frequent compared to the time that you are allowing the money to accumulate, right? So usually your rates could be slightly lower compared to what you would otherwise give them the benefit. So you have to estimate on the conservative side. Now there are two conventions. Again, one convention is a little bit old, which is when the computers were not there. The idea was you simplify the calculation, because this is usually not going to be a huge difference between the payment period and the compounding period. So you make an assumption that there is no inter-period compounding. So you just disregard the fact that there is at all a compounding. How to handle those situations, I will tell you. But nowadays, because of the availability of calculation power, this is not a case. So you need to, again, you can actually do the estimation of equivalent rate. Formula remains the same. Equivalent rate per payment period. You can convert, last time I showed you 1/13 kind of a calculation with a power 1/13 instead of a power 13 kind of a calculation. You can still estimate the equivalent effective rate per payment period and still go on. But I'll also introduce you this no intercompounding concept, which is sometimes still, especially if you are going into this government jobs, this is the classic question you will get from, because this is the toughest question they ask in construction management side of this stream. So your IES and all papers, you might have these kind of questions. Okay. But again, no intercompounding period it can have huge impacts if you're dealing with large number of transactions or large volumes of transactions. So of course, it's not an assumption. Just to make life simplify, people made this assumption of no interperiod compounding. What happens is, this kind of method actually breaks the golden rule of all the calculations that we do, which is shift the cash flow series, which is a cardinal sin in our course, but this rule actually does that. So what happens is, all the negative cash flows are all made at the end of the compounding period, and all the positive cash flows are regarded as made at the beginning. Why so? In order to maximize your profit as a person, you want to show the maximum profit. So your cash flow occurring later, or a negative cash flow occurring later, is slightly less powerful on the present worth. If the same loss is happening in the beginning, it has more powerful impact on your present worth, because, for example, one loss is happening at the year 1 versus another loss is happening at year 2. If you calculate the contribution to present worth, this value is divided by only 1 plus I, but this value is divided by 1 plus I square, right? So its contribution is actually lower on the present worth the higher you go. So therefore, it makes sense that all the losses you shift towards the end, but all the profits you shift towards the beginning of the compounding period, in order to show a little bit on a higher side of your net cash flow series. Okay, let me show you with an example. In this case, we are converting an yearly cash flow series to an equivalent quarterly cash flow series, when the assumption is that there is no intermediate compounding happening. Okay, so we are dealing with quarters, right? So the convention is this first period remain unchanged. So it does not even follow its own convention. That's what my worry about this method is, because you are not doing anything with the period 0. You are not shifting the period 0 value to end of the first quarter. You are assuming that it is there. Now, what are the negative cash flows happening in between periods, this 0 to 3 months, which is in the first quarter? So you shift all of this, take a sum and bring it to the end of the first quarter. Okay? Between months 3 and 6, total 175 on the negative cash flow. That comes at the end, but the positive of this cycle, which is what? 90 and 90, that gets shifted in the beginning. So your net cash flow series and this time will become 180 and 175, like this. Okay? Again, whatever is happening here remains here, but this 45 comes to make it 165. The total loss in this period becomes 50, which goes towards the end. Making sense? All the negative cash flows, you are shifting one period or whatever is happening in the intermediate, you are shifting it to the end of your compounding period, and all the positive you are bringing at the beginning. Whatever is happening you assume they are happening at the same. They do not get changed. Okay? Clearly, if instead of such small numbers, you can add like a 180 million kind of a number, you can easily imagine the error it will have in the absolute sense, right? So not a good method. It is a little bit of an old accounting practice. Banks used to make their life simple. So that's how they used to do this, but no longer applicable. Still, sometimes somebody can ask the question on this. So that's why the concept is introduced. Do you know, anyone knows how banks earlier used to calculate interest rate on your savings account? There was a formula which I think I read in my 5th standard or 4th standard somewhere. So what they used to do is, they would calculate the minimum balance in the first 10 days of every month. And for that month, they will give me interest on that minimum amount on the first 10 days. So it doesn't make any sense. You can easily game. You can keep the balance on your first 10 days very high, then start withdrawing the money to maximize as a customer. But banks would use, to make their life simple, they would do this kind of a simple estimation to do the calculation. Therefore, origin of this kind of methods now no longer valid. All right. Any doubts? Okay. So this is in case there is an interperiod compounding. So in that case, the same formula what we have been using, you have to estimate the I% per payment period. That formula is the golden rule. And instead of you dealing with M as a natural numbers, you are dealing with M as fractions now, because they will become smaller values. So you can estimate weekly, daily rates if needed, and then use those rates in order to properly account in your formulas. Okay? Alright. So essentially, if you are dealing with formulas, then there is no problem in changing anything. All you have to make sure that you are calculating I for payment period and use the number of payment period in the calculation. Doesn't matter whether your cash CP is higher or lower, blah, blah, blah. This kind of problem only comes when this inter-period compounding you are not considering. Okay. So that's complicated life to a slightly simplified life if you want to remember how the formula system works. All right. Just an error that I just wanted to highlight, and that's where we will, I think we'll be reaching towards the end. So far what we have discussed is always change the effective rate per payment period. Right? That's the formula that's the golden rule I am giving to you. But in some cases, you will have alternate possible. For example, let's say you have this, essentially you are changing n instead of I. You try to make n as the number of compounding periods instead of changing I to be equal to per payment period. Right? How to do that? Suppose there is a formula here. This is 15% per year compounded monthly. Your original question was you need to find for a 2-year span. Right? So what we had done is 15% per year compounded monthly. You get an answer of 1.25% per month compounded monthly. Now you convert n to 24. This, is it equal to, this is the one we calculated. We first converted onto an effective annual rate and then we use 2 as the number of years, right? Here what I am doing is I am only using the compounding period and then I am changing the number of time periods to be equal unit to compounding period, right? So what is happening, instead of n being, I have the rate, reduce rate, but I am transforming n as 24. Calculate, are they same? Confirm 100%. Are they same? Equal or not? Equal? Yes. So this method works only when you are transforming P to F or F to P. It doesn't work for any other formula. A to P to F or whatever. Doesn't work for any other formula, this method. You know the have you noticed the difference in the two methods? First, in the first method, we are converting the rate to equal to the payment period unit, and then we are using the number of payment period in the formula. But in the second, I am converting the rate to equal to the compounding period, and I am using number of compounding period as to modify my n value in the formula, right? That's the two differences. But all I'm saying is that this formula only works, this will give you consistent, both the approaches will give you a consistent answer only for the P and F transformations. But all other transformations, it won't give you the consistent answer. And that is an assignment question for you. Think on why. And prove that it will actually not give the same answer, not using values, but logically. Okay? Draw the cash flow diagram and convince yourself that the method 1 is always the correct one, which is converting your rate to the effective payment period and using that as a formula. Okay? If you are not able to get this answer, let me know. We'll try to cover it sometime soon. But it's available. Draw the cash flow diagram, you will be able to get an answer. Why it is happening, why it is not happening. This is a bit tricky. It will be more handy when you are dealing with the real world situations. Alright, so let me bring you back to a little bit more simpler life of what we know. This was a slightly complicated detour, but practice this concept. If you want, again, thousands of problems are available on this subject, online, wherever, but practice this concept. You will make mistakes otherwise, okay? And pay attention to, from now onwards, whenever you get the questions, pay attention about how is the rate mentioned. So far in your assignment and quizzes, it was a simple assumption, but now pay attention to when the rates are. I'm not going to say that this assignment is only focused on rate related. This concept can come anytime. So just pay attention to the wordings around that, right? Let me bring you back to the simpler discussions that we were having, which was I had shown you how to estimate the present worth, annual worth, all this formula, P by A transformations and all. How do you actually use it? What is the fundamental uses of all this what we are learning? And I also introduced in the beginning of the course that one of the major role for this particular subject is to evaluate alternatives. If there are multiple methods to do the same thing, which is more financially sound compared to the other, that's the primary question you are going to answer in this course. And for that, we will learn a different methods from now onwards. For next couple of weeks, that will be the focus of the class, right? One thing, so some of the summary, I'm just giving you a brief. We will be discussing about these kind of topics. They will come. One foremost assumption in all these, when we are evaluating the alternative, is that each alternative is same level of technical soundness, right? The basic function that you want it to serve, all the alternative will serve that. You cannot compare apples with oranges. You can compare apple 1 versus apple 2, right? So the basic functionality of what an apple should do must be done by an alternative. Otherwise, you can't compare in the same pool, right? And the second is, we are also making an assumption that apple 1 is equally acceptable to the society as compared to apple 2, which is not the case in many situations. In real world, it is extremely hard to find alternatives which are equal, almost acceptable from an equal perspective. Particularly, all the companies in the world are actually based out of product differentiation, right? Apple becomes different than OnePlus because it brings certain features which certain users value, compared to OnePlus brings certain features which brings certain value. The basic functionality of what a phone is remains the same in both, right? So you can still compare, but you will never be having the social acceptability, but that's an assumption that we are making in this kind of a evaluation whenever we are doing. And then the only thing remaining is the financial and the economic viability side of it, which we will be studying on how to calculate. Okay. There's also two types of projects or two types of alternatives that you can be defined. One is mutually exclusive projects, which means that if you put money on one project, you cannot put money on the other project. By default, you putting money on one makes you exclusive to only that project. So you have to select only one alternative out of the all, right? And in that, in certain cases, doing nothing is also an option. Suppose I am asking you, you invest in option A versus option B. You will say both these options are losing me money. Why would I even invest in option A and option B? So doing nothing is also an option, right? That's a by default option in all these kind of questions when you are dealing with mutually exclusive alternative. Some projects are called independent projects. In this project, you can choose multiple projects which satisfy your criteria. Let's say you have set up a criteria that total I can spend $1 million. So you rank the projects according to some sort of a criteria. And you say that in 1 million, I can execute 3 projects. So you execute all 3, because investing in just one, which is let's say only a $50,000 project, does not ban you from investing in another smaller amount project, because you still have that money to invest in, right? So this is quite an important distinction. We will be dealing in most cases mutually exclusive projects by default in this course, but independent projects can also be managed given I give you the criteria of accepting what a project is, when the project is viable for you. Okay, so this is where we'll start from tomorrow